Hello, good afternoon or good morning, whatever time you are reading or watching this PowerPoint presentation. I hope that you have learned already in the past the based from the uploaded first segment of our PowerPoint presentation, although I have already given some of them in your USB, but this will be a supplemental to your modules and also to your first video presentation. So encourage others also if they are not able to obtain this, you can share with them once you have downloaded already in your or your USB or in your cell phone. So one of the most important topic that we need to know about photography is light. Remember in my first discussion that light is one of the elements of photography. Without light, there will be no photography. So what are those things you need to know? Basically, there are two sources of light. We have the artificial. So this is the artificial and the natural. So of course, when we say artificial, how will we define that is when it is human made, and natural is when God created them. So if you believe in God, that's how you define it. But to me, since I believe in God, then I would say that's how I will define it. But both of these natural and artificial are being used in photography, and they are both also useful and important. So in the absence of one, you can use the other one, but that's not my important concern. My concern is when we talk about light, there are actually what we call as condition of light. So when we see condition, refers to what does light looks like whenever you arrive in the crime scene. There are many parts of your camera that you need to adjust, like the ISO, the shutter speed, and the f number. And one of the bases in adjusting that is the condition of light, which means to say that the moment you arrive in your crime scene, one of the things you should put in mind, aside from attending to the needs of the victim, is to look at around you and see what is the light condition. Is it hazy, is it dull, or is it bright? As I've said, that is because that is your basis in adjusting three important features in your camera. So the first condition is called hazy. So hazy is defined as a condition of light with a transparent shadow. So our basis in determining the condition of light is simply look at the shadow. So if the shadow is transparent, like the one you see in your screen, then that is what we call as hazy. And the other condition of light is dull. During nighttime, you don't have shadow. So how would we define it? When there is no shadow. Then another one is bright condition of light. When there is a strong shadow, then that is what we call as bright. So again, these three condition of light are basis also of adjusting three features in your camera. Remember that what we are aftering for is the quality of photograph, not the quantity, not how many photographs you will take, but the quality, because the quality photograph is the basis of the court in accepting it as an evidence. So how will you make it quality one? One is you adjust the ISO, the f number, and the shutter speed. What are your bases? These three: the hazy, the bright, the dull condition of light. So take note of that. And then another thing that I would like you to understand in as far as light is concerned is called electromagnetic spectrum, or in short we call it spectrum. When we say spectrum, these are actually group of rays of light. What does it mean? Just imagine, or let's make an analogy. When you put flowers together, how do you call it? how do we call it? We call it bouquet. When fish goes together, we call them fish. When mountains are grouped together, we call them ranges. Uh, when people are gathered together, we call them crowd. So rays of the sun are many. When the sun shines from the east, it emits several rays of light actually. And what are those rays? We have the radio waves, we have the microwave, the infrared, ultraviolet, X-ray, gamma rays, the white light or the visible light, and there are many of them. So if you put them as one, then that is what we call as electromagnetic spectrum. It simply means group of rays of light. And how you are going to understand that better? So this is it. This is another illustration, and you have here the gamma rays, X rays, ultra, infrared, radio waves, and all of these are useful in our life and also in photography. So we cannot be able to watch TV if there is no radio waves. We cannot watch internet too if there is no radio waves. If we want to see invisible objects, we use this too. If we want to see internal parts of the body, we use this, and likewise with this. But the common ray of light we are using is this, the visible ray or visible light, or known as white light. So the white light is not only one, it also composed of RGB, the 8 colors. So this is what we are using every time we use our camera, be it cell phone or the single lens reflex camera. Alright, so that's what we call as spectrum. And then another term is wavelength. So what is wavelength? Okay, the light, if this is the sun, this is the sun, when light rays comes here, it doesn't move straight. Instead, the light move like this. So it moves like this, right? It moves like this, and the scientist was able to measure the distance between one crest, we call it one crest here, one crest to another crest. They are able to measure the distance. All right, and let me tell you that distance is not 1 kilometer. It's 1 millionth of a meter. So meaning not even 1 centimeter. It's shorter than 1 centimeter. So it's very, very close distance. But the scientist was able to measure that, and that's how light travels. It's like this. So the distance from one crest to another crest is called wavelength. This is another illustration. So we have what we call as amplitude, refers to the height, and then one whole like that, a complete wave like that, is called frequency. Okay, then another important thing we need to know also, in as far as light is concerned, is behavior of light. So we have condition of light, and we also have behavior of light. When we say behavior of light, it's also known as characteristics, how light acts or how light behave. Now, to give you another illustration, this is the sun, and when rays comes from the sun and emits its rays continuously to the water, the light rays do not move straight, right? Instead, it moves like this. When it reaches the water, because of its density, it does not go straight. Instead, it refract like this. It refract or it curve, right? And as a consequence of that, because it's curving, so what will happen is uh, what you see in your eyes when you try to see fish underwater is, it seems it's here, but the actual location is here. So the light is the one responsible for this state. So why is it like that? Because the light cannot move straight. So that is one characteristic. We call that one as refraction. All right, that is refraction. In camera also, refraction occurs. The different characteristics of light is actually occurring inside of our lenses. That is why we are talking about it. Then another behavior of light is called interference. So interference occurs when this source of light emits its light going there, and another source of light emits also its light over there. So they interfere somewhere here. That's why it's called interference behavior. Then okay, next behavior is transmission. So transmission, so meaning it goes to the other side, isn't it? So this is the glass, and then the light rays from here went to the other side. That is what we call as transmission. So if that is the source of light, then the light pass through, but after passing through, it produces more rays. Then we call that one as translucent transmission. This occurs when this medium, when you say medium, it could be a glass, is broken, or when it is rough. So it produces several rays. That's what we call as translucent. Okay, another one which is the opposite of translucent. For example, that is the source of light, and then it's the ray of light, and there is a medium glass. Then when it went through, there is only one ray of light. We call it as transparent transmission, right? Okay, so another behavior of light, we have, for example, the source of light, and ray emits on a medium, another probably a glass, and then it's like that there, and then it reflects. So we call it reflection. But there are two kinds of reflections too. So we have specular reflection. This is already an example of specular reflection. One ray hits the glass and then reflect only one ray. That's specular. Okay. Another kind of reflection is called diffuse reflection. So how does it work, or what is it look like? So it's like that. Ray of light hits the medium, produces 3 reflections. So we call that as diffuse reflection. So very easy, isn't it? Okay. Then that's the difference. So you can see here, specular reflection, one single ray, only one ray is reflected. Diffuse reflection, one ray produces different rays in different direction. That's the difference. Okay, another is diffraction. So diffraction occurs when the medium, for example, this one is the edge of a table that is reflectorized or glass, and then what happens is the ray of light hits that table, and then some rays are reflected, some are transmitted. Okay, so we call that as diffraction. Another thing that you need to know also, so we are already done with light. That's the other element of light, element of photography. And one of the important part of the camera is lens. So lens is the one responsible in bringing image to the sensor. Imagine, have you not wondered how is it possible that you are 5'4" in height and then your image was able to enter in your very tiny camera or tiny cell phone camera? It's amazing, isn't it? That is because of the job of the lens. Okay, so the ray of light carries the image, but what makes it fit in your camera is the lens. Lens is the most expensive part of the camera. Yeah, when you buy worth 40,000 camera, that is because of its lens. Now there are different types of lenses according to shape. We have the convex lens. The convex lens is this. Remember and look at the image, thicker in the center and thinner at the edges. While concave lens, thicker at the edges and thinner at the center. This one, the convex lens is capable of producing an image. It can bring image to the sensor, while the concave is incapable of bringing image to the sensor. That's why they call this one as negative lens. But in a camera, we are using both of these because they complement each other, meaning they help each other. This one has shortcomings as well as this one, but if you put them together, they are like perfect. It's like husband and wife. So that is how it works. Then illustration for how does the concave lens works. So when rays of light passes through, they will diverge. Pass through, they will diverge. They will go different direction. That's why we call this lens as diverging lens or concave lens, or otherwise known also as negative lens. So this is how they work. So for example, the convex lens has imperfectness. It's not perfect, but if you combine it with this, they become perfect. So I will discuss later on how this works. Another illustration, how do they work? So you can see that the convex lens is also known as convergent lens. When rays of light passes through it, they will converge in one point here. They will converge. That's why it is called converging lens. While this one, when it passes through, it went up and went down. They separate, so they call it diverging lens. Okay, inside of a digital camera, this is how light looks like. You can see here that there is a reversion of the light. That is because the light passes through here. The light passes through here will refract. They will curve, and so you will notice that the green color of light here on top went below or at the bottom when it enters in the sensor. So this is the sensor. This is where your image is being captured and being recorded. Right? So here. So that is where we find our sensor. And you will notice also here that there are several lenses used. So alternately, the concave and convex are used in this part. If you notice, there are so many. That's why that kind of lens is expensive. For other ordinary camera, like our cell phone camera, uses only a concave and convex lens. So they are just combined, and then the rest, why the defects are fixed, because it is being fixed already here electronically by an artificial intelligence. But for a camera like this that doesn't have so much apps installed in it, then this is really working for them. Okay, then lens also are categorized by angle view. So we call it types of lens according to angle view. When we say angle view, refers to how wide or how narrow the lens can see. For us human, our eyes are also limited. It has also an angle view. When you focus your eye straight, you cannot see sideward. You cannot see the side, because what we can only see is 45 to 60 degrees angle view. That's how what's the range of how human eyes can see. Lens is also like that. It has also limited range, and they have a very specific use, especially in law enforcement. For example, the wide angle view lens, it has more than 60 angle view here, more than 60 angle view. It's wide actually. We cannot already see some of it if we use our eyes. Now, remember, more than 60 degrees angle view. So where can we use this? These are very useful in some crime scenes. Like for example, if your scene is very wide, where evidences are scattered, or the area is crammed, where you wanted to photograph the whole view in one shot, an evidence in one corner, another is in one corner, and you want to photograph them in one viewing because the judge usually demands a picture of that, then wide angle lens is appropriate. But if your subject is very far, then there is a corresponding lens for that. We call it telephoto lens. Telephoto lens, from the word tele means far, and then photo means light. So you can view subject from a far distance. So it's very effective in some scene like fire scene where you cannot go near, or for intelligence gathering. And also the problem, however, is telephoto lens has a narrow angle view because it can only see less than 45 degrees. It's so narrow because it's really for far distance subject. So that is telephoto lens based on angle view. Then another type of lens is we have normal lens. Normal lens because it is the same as our human eye. Our eyes, as I've said a while ago, can only see 45 to 60 degrees angle view. And then so whenever you buy cell phone today, cell phone camera or the single lens reflex, any ordinary camera, it is already set on or default on normal angle lens. So that's the comparison. As you can see, it's the angle view is limited while this one is very wide. There's a difference between normal and the wide angle view. And then where is it already? Okay, so those are the different types of lens according to angle view. Now another thing that I wanted you to know, okay, just follow me. Look at this. For example, that is your subject. By the way, in photography, when we say subject, this is the subject, the one that you are going to picture. So imagine that this is so this is your camera, right? That's your film before, but today this is called sensor. For digital camera, this is called sensor or electronic sensor. Okay, so that's your camera. Now, how do we call that? Remember I told you that when light rays comes from the subject, passes through the lens, they will refract like that, right? And from here, they will refract. And then you will notice that the light rays inside of the camera meet somewhere else. They meet somewhere else in here. So how do you call that? We call it as focal point, meeting place of rays. once they pass through lens. Okay, another one, so we call that part pointed by arrow as focal plane. And how about the distance? Distance between the center of the lens, we call this center of the lens, and the focal plane. So how do you call that? Let me erase first. So we have here the center of the lens and that focal plane. If you measure that, we call it focal length. Now, what is the importance of that focal length? Okay, let me explain. So focal length is the distance, isn't it? But you can change that. So for example, this is the focal length. Let me draw another one here. So it's the focal length, and you can actually move this closer here. So for example, that's the center. You can make the center adjust here. So the distance is already short. So if you adjust that, that's actually zoom in your camera. When you move it closer, what will happen to your subject? The subject might change in terms of size and angle view. So short distance produce a smaller subject. So the size of this becomes smaller but wider in scope. While if you move the center of the lens away from the focal plane, long focal length, then the subject becomes large, okay, but narrower already in angle view. Please remember that. Okay, so that's another illustration of focal length, distance of the sensor to the center of the lens. And then okay, another thing is what we call as depth of field. Depth of field, listen to this, refers to area in the subject that appears to be in focus or clear. You will notice that this portion is blurred, this portion is clear. So the portion that is clear is called depth of field. So that really happens, and the reason for that is maybe your cell phone camera or camera has a defect, or you have adjusted your f number or your focal length, so it also changes the depth of field. But remember, depth of field is area that appears to be clear or in focus. Okay, so another example of depth of field is still in the center and in the side, but some depth of field, okay, let me look at some more. So you see that the depth of field is in the center, okay, but other depth of field you can be in the background or in front. So this could be clear, you can do that, and this portion can be blurred, or you can make this front clear and make the background blurred. So the clear area is called depth of field. What else? Okay, so another thing that we need to talk about lens is called aberration. Aberration refers to a defect. So not all lenses are perfect. There is no such thing as perfect lens. There is always what we call as inherent defect. When we say inherent, these are innate, natural, or inborn defect. The moment they are manufactured in the company, this defect is already there. It's not actually a defect, but it is by nature. It's by nature of the lens. You will understand how it really works later. So what are the defects of lenses? Okay, first one is called spherical aberration. Spherical aberration happens when rays of light, this ray of light passes spherical shape of lens. You know, lens is always spherical. and concave. There is no such thing as circular lens. So spherical, you cannot reinvent that. Like wheels, you cannot make a flat wheels. It's always round. So lens is also like that. And because it is spherical, there is a natural effect which cannot be changed unless you change the size of the or the shape of the lens. So what will happen here, when rays of light passes through here, they will refract, and it passes through here, they will refract. If you compare to the rays passing at the center, they don't refract much, they don't curve much. So you will notice now that there are already two focal points. So that's the effect. If there are two focal points, the result of that is blurredness of photograph. So let me show you the effect. So remember, spherical aberration results to blurredness. This is it. This is the result of the spherical aberration. You see clear here, blurred in here. And then another result of spherical aberration. Now, how will they fix that? How did they fix that? Why is it that we don't see so much lens defect like that today? Because our companies, the companies producing camera, combine convex and concave lens. As you can see here, they already combine convex and concave. So this one is the lens aberration defect, spherical aberration. You will notice that there are different focal point in here in here. So you will notice that supposed to be these rays of light will go there, right? But because of the presence of the concave lens, the rays went there. So when it's supposed to be there, but because of that it went here. So there is already only one focal point instead of that one and that one. So the concave fixed the problem of the convex lens. Likewise, another defect of lens is called chromatic aberration. Chromatic aberration is also by nature. You know, when light passes through lens, when white light passes through lens, there is actually a lot of color of light, Roy's vive color, and these colors passing through here have different speed, because remember 400 to 700 millimicrons. So they don't go into the same direction, the same focal point. The red color, because of its speed, it will go here, and the violet comes here. So that's why there is a color defect, which is called chromatic aberration. So this is the example. Oh no, this is another illustration. So the blue is here, the green is here, and the red is here. So three focal point. So the result is like that. So I want you to observe this portion. There is reddish color in here, then reddish color here, reddish color in there. So those are because of chromatic. That is what we call as chromatic aberration. Okay, then another example. Yeah, that's one, and it came from here. So how to fix that? The same with the spherical aberration. Simply add proper concave lens, then the rays of light will have single focal point. Another defect is called coma aberration. Coma aberration occurs when rays of light enters obliquely, as you can see in the illustration, the light coming from a different direction, and it's hard for the lens to fix it, and so you will see comet formation or pierce formation in your photograph. So it's like this. It enters there, the obliquely light came from here, and you will see something like this, either on the side of your photograph, in the middle, or in the bottom. Another defect is called astigmatism. Occurs when you can no longer see a cross as cross. It looks like this. It's like curve. And another defect is distortion. Distortion shows a defect like this. There are two kinds of distortion: barrel distortion and pincushion distortion. So the illustration is when you see that a straight post or a straight building, for example, at the edge curve outward like this, it's called barrel. When the curving of the straight post or building is curving outward, we call it pincushion. And then this is another illustration. You will see that the image bow outward. This is barrel distortion. And then another illustration of astigmatism. You will see here the one suffering from astigmatism, right, is when the rays of light enter in the eyes of human. Lens is patterned from human eyes. It's exactly the same as human eyes, so they function like that. So if the light rays enter here in the eyes and it has a problem, the eyes has problem, then the rays of light will go to different focal point. There is also what we call a sensor here of our eyes, and if it goes to different direction, the brain cannot read it well because it has two focal points. So what will happen is it results to blurredness. How to correct it? So you will see that there is a correction here. So for example, doctor recommends you to use eyeglasses. So the eyeglasses will fix the light first before it reaches the focal point, so that there is only one focal point. It is similar to lenses. Then that's the effect of the astigmatism defect: corrected one, uncorrected. Okay, so another thing that I think is important also for you is what we call as F number or aperture. So let me clarify this. Inside of this lens there is a small hole, and the small hole is called aperture. Now the size of the hole is called F number. So the hole itself is aperture, and the name of the size is F number. That's why we have 1.4 to 22. We call this F22, F1.4, F2. So whenever you see this, imagine referring only to the hole inside of the lens. It's where the light enters, right? It's the light enters, and you will see that it has different shape. This one is wider, while that one is smaller. So this is just used to control the amount of light entering in a camera, which is called lens speed. So it regulates the amount of light entering in your camera. We call it lens speed. So it doesn't refer to how fast your lens moves, but it refers to how much amount of light your camera can absorb, and it varies depending on the condition of light. So for example, if your subject is in a dull condition of light, is so dark, then you will use this because you need to let more amount of light to enter. Otherwise, your image will be underexposed, so it's going to be dark. While if your subject is in a bright lunchtime and it's so sunny, then you use this, so that even if you allow small amount of light to enter, but since it is strong, then it is still enough to show the image that you wanted to see. So that's the use, isn't it? And then take note, the smaller the number, 1.4, the wider the size. The bigger the number, the smaller the size. That is how it works. So the highest number is the smallest size. So it varies. It depends on what lens you are using. But sometimes the highest is 32 or 36, right? We call it as F number. This depends on the condition of light. So you can adjust that. Okay. Then another illustration. So you can see here the lowest number, and highest number is the smallest. What else? Okay, so this will illustrate further how does F number works. So for example, low F number, so meaning 2.8. So this is what you will see. 2.8 is the widest, and it's wide. It's very wide lens opening, so it's bright because you allow light to enter, more light to enter. This shutter speed, we will talk about this one later on. I will still go back to this discussion, but as of the moment, what I wanted you to see is how does F number works. While here, you will notice that it's a little darker. It's high number, meaning high number like F32. If you use that, then you will have a little darker image because you allow only a small amount of light to enter because you make your hole so small. So what do you expect? It's dark. So that is how it works. And then last illustration, you see here it's very wide. So this is the result. You will see that there are changes that take place here. It's so narrow already. So narrow. It's very wide, but you will see that your angle view has changed, meaning it's bright but it's narrow. While here, less light, you allow less light to enter, and so it is a little darker. This is in a bright condition of light. So you will notice that which one among these photos is far better. So this could be one and this one, but you will notice that when you change also this one, this size, there are two things that will happen. One is the brightness, second is the angle view also changes. So this number here you can no longer see, here it's already visible. So for the meantime, I will end here the session. It's already 40 minutes and it's hard to upload a very high bytes of a video clip. So I hope this has helped you. Please encourage your classmates to watch them. It's not enough really to use your modules. So please let us help each other. You need this one not only for your exam in the final, but you need this one when you go to your career or even in your life. You will be needing this. So let us help each other. So I will still have two more or more than two or I don't know how many segment I will still work before the final. So I hope that you are adjusting, and if ever you have problem with your class, let us know.